Okay, so for this question, the first thing we do is label the directions of our my and mz. So they gave us m and they say it's going this way. So we know it's going up and to the right. So my and mz. Now we have to see which way the moment arrows are going. So for this, we use the right hand rule. So I can't show you my hand right now, but if you get your right hand and point your thumb towards MZ, you see that your fingers are coming towards you, right? And so this is how I imagine it. So it's towards you. So if you imagine like you're standing right here and your fingers are coming like towards you, it's going clockwise. Okay. And for these questions, clockwise is negative. I'm just gonna write that down. Clockwise, negative. Then counterclockwise is positive. And so for this one, they're coming in. So it's going clockwise. Another thing you can do is like, you can like pretend that you're standing here and then look at it, like pretend you're standing right here and you're looking at that and you see it's going like, ooh, this way. So that's clockwise. So that makes MZ negative. So MZ equals negative 25 kilonewtons. And so negative 25. Z is the X, so we do cos 30. And then when we do that, we get negative 21.65 times 10 to the 6 newtons per millimeter. That's after converting this. And for my, we have to find out what symbol it is, right? Like, so which direction it's going. So you point your finger towards the my arrow, and then you see it's going this way, like this way, right? This way. Oh, and also this one was going this way. So MZ and MY, that's kind of ugly. MY, that's uglier. Anyways, you do that, and then you see it's also going clockwise again. So MY is also negative. Like you pretend you're standing here and you look at which way this is going. Like you look at your fingers and it's clockwise. So also negative 25 sine 30 this time. And then we get, oh God, we get negative 12.5 times 10 to the 6 newtons per millimeter. Okay, so we have our values. We can note those. And then now we have to use the stress equation. We need to figure out which one to use. Do we use the general section one or the principal axis one? So for this question, they're asking for the intersection of the neutral axis with the lines AD and AG. When they're asking for lines, you use the general one. If they're asking for intersection with like the y-axis or x-axis, then you use the principal axis one. So we're gonna use the general one. So they literally give you the formula. You usually add P over A when they give you a P, but we don't have a P. So we just do it without the P. And then, okay, you just plug like literally this and then your I, Y, I, Z stuff. And then you end up getting this. I'm not gonna like do it all because like you know how to do that. 502.146 Y. We're making an equation, so we have that, and then 502.146 Z. Okay, so that's our equation. We have those. And okay. Now for part A, we need we need that equation. That's our equation of the neutral axis. And now they're asking for the intersection with line AD and AG. So line AD and AG. And so let's do equation of line AD first. So the equation of the line is literally just like you get this line and it's the distance from that line to your neutral axis. And like this is pretty easy to get that distance. You just do 120 times 3, which is 360. Take away 208.75. And you get 151.25. But the part where everyone's like getting confused is how you get like this should be negative. So like how do you make it negative, you know? And for this is a trick that I use. Okay, so I go to part B and they're asking for like the location of the maximum tensile, maximum compressive stress, right? And we know that the moment arrow points from tension to compression. So tension to compression, right? So this, like, you know, this stuff is, okay, like this is tension for MZ, but compression for MY. You know why? Because like this is this line, oh God. Oh, oh, okay. Yeah, like you just look at the way that the arrow is pointing. And so I know my maximum tensile stress is gonna be, I already know the location, like I don't have to do any calculations. It's gonna be point A. It's gonna be point A because this is going from tension to compression. So this side is compression, this side is tension. This arrow is going from tension to compression. So all of this is tension. So A is tension for MY and MZ. And then J is compression for MY and MZ. So A is going to give maximum tensile, J is going to give max compressive strength, right? And so I know that. I know that. So, and for part B, you use this equation and you plug in the Y and Z values for point A and point J, right? And for max tensile, I want this stress to be positive. And the only way that this can be like the max positive is if Y and Z are negative, because negative, it's gonna be a negative is gonna give me a positive. Another negative and negative is gonna give me a positive. So I'm gonna get like a big number. And so I know that Y and Z should be negative. That's why for line AD, I know it should be negative because A is like it has to be negative eventually. Okay, and this is length. This is Y. And so for that, I have to intersect it. Intersect with my neutral axis. Oh, and also like we make it equal to 0, like that's the equation, right? Equal to 0. So we do Z equals, after you calculate this stuff. Oh, actually, no. Yeah, I can simplify my equation more. It becomes 0 equals negative 0.0346 Y minus 0.0058 Z. And then I need to find Z because I just found Y, right? I just found Y from this. And so Z equals 0. I'm just isolating for Z here. 0.0346Y over 0.0058. And then I plug that in. 0.0346 times negative 151.25 over 0.0058. And then I get negative 902.2844 millimeters. So that's my answer for one of them. Now I need to intersect line AG with the neutral axis. This occurs at Z, because AG is this one. We need to find this distance, which is 100 plus 140 plus 100 minus 161.25. So 340 minus 161.25. What's that? That's negative, not, oh, it should be negative, but just the magnitude of that is 178.75. And then we look at the direction again, and we know AG is distance. Oh, once again, like you look at A, and then you know it's negative because you just look at the second part and you know A is tensile. And to maximize the value and make the stress positive here, Y and Z need to be negative, the biggest numbers they can be for tension. And the biggest numbers you can get is at A. Like this is maximum, this is maximum. You know, the biggest Y and Z values you can get for tension happens at A. And they happen at the corners, like all the time. So yeah. So yeah, that's how I think of it. I know another way people do it. This actually doesn't make sense to me because I can't memorize that much shit. But you know how they're like, oh, like it's negative. Okay, so Y is negative here, Z is negative here, Y is positive here, Z is positive here, and then negative, positive, positive, negative. You can memorize that if you want. I mean, it's not that hard, I guess, because you just memorize like this whole quadrant, the Y and Z are negative, and the opposite has to be positive. And then if Z is going this way, yeah, I don't even know how to memorize that. I'm not gonna memorize that. I'm just gonna do it my way by like looking at the second part and then seeing what sign works out. Okay, anyways, I did that. And now I intersect. Oh, this is negative, by the way. Oh god, my writing is so bad. Negative with an A. And so at Y, now I have to isolate my equation for Y. And so I get 0.0058, 0.0 negative 0.5 over 0 Z 0.0346. I just isolated and I get Y equals negative 0.0058 times negative 178.75 over 0.0346. And then I get 29.96 millimeters. And so those are my two answers. That's how I do it. Yeah, so to sum up the first part, what you do is you look at your M, you use your finger hand rule, you pretend you're standing here or you're standing here. If it's going clockwise, then it's negative. If it's going counterclockwise, it's positive. So you do that. And then you use your general or principal axis equation, depending what they're asking for here. And then you intersect your lines with the neutral axis, find the distances. And then to determine if it's positive or negative, you go to your second part and see stress, whatever happens, right? So you need to see what makes it maximum. And then for part B, where they're asking for location of max tensile and compressive stresses. Okay. So for this, yeah, like I said, I wish I had something to like point with. Do I? Oh, maybe that. Okay. So let's do max compressive first. We know the moment arrow points towards, like the arrowhead points towards the compressive side. So for MY and MZ, so it's pointing this way, so this section, and then MZ is pointing this way. So this section, this quadrant is the max compressive, and it happens at the very edge. So we know that max compressive at J. And then we need to find the location of J. And this is where it gets confusing again, but it all works out because you use this equation, right? Let me rewrite it. Negative 17.37. Actually, I don't want to use that one. I'm going to use the simplified one. 0 equals, not that. Theta, yeah, I'm going to use this one. Negative, negative 0.0346. Y, take away 0.0058 Z. And for this one, we need to find the Y and Z. Okay, so listen, for this one, we have max compression. So we know that this has to be the maximum negative number. And for that to be the maximum negative number, the magnitude has to be the highest for Y and J, but the signs should be positive because, negative, negative, we get a big negative number. That's what we want. So that's how we know that our Y and Z coordinates should be positive. And also, okay, I don't know if we can find it, but if we do find it, we can just memorize that. You know the thing that I showed you before? Positive, positive, negative, negative, and some other bullshit. Just memorize that. Because yeah, positive, positive, so we know both coordinates are positive. So for J, our coordinates are 208.75, this one for Y. For Z, it's 161.25. Both positive, because that's what we need. So max at J, negative 0.0346 times 208.75, take away 0.0058, 161.25. So our sigma J ends up being negative 8.15 megapascals. See, so that's how you do it. Like you literally look at your equation and see, like where it has to be maximum compressive, right? You know the location. So you just use your signs accordingly. That's basically how you do it. Okay, and now we need max tension. Same thing. We know that occurs. Max tension is where the moment arrow is pointing away from. So this, and you look at this. So this region, and then I mean, yeah, the top region, and then this side. So max tension occurs at A. So once again, max tension, we need our equation, the same one above. I'll just rewrite it again so you understand better. Damn, I'm really taking my time with this. Yeah, anyways. I'm just trying to explain it well, like what's going on in my head. I'm just trying to explain it that way. So for max tension, we need to make this the biggest positive value you can because it's tension. So we know that Y and Z, we need to make it negative. So these negatives and these negatives, they cancel out, gives you a very positive number. Okay, so we just need to find the magnitude. I literally don't look at this for the direction, but you can. Once again, we can use this thing, negative, negative, positive, positive. I forgot what goes here, but we can memorize that if we want. So negative, negative, the points at A should be negative. Hold up. So the points are negative 151.25, negative 178.75. So that's because we do 360 minus 208.75, which gives you negative 151.25, and the distance, the horizontal distance, and this would be 340 minus 161.25, which is 178.25. They're both negative, and so you just plug that in. Max tension 0.0346, 151.25, negative 0.0058, negative 178.75. Then you get an answer of negative 6.26 MPa. And that's your maximum tension. The biggest positive number you can get and the biggest negative number you can get. Literally just base everything off of the equation that you made, and then you just figure the signs out by yourself. And figuring out the numbers is super easy. And so that's all. I'll do another question to So you can like compare, compare that my method works for like every other question, not just this one.